Hello students, welcome to the first lesson on trigonometry. This is chapter 8 in your textbook, Introduction to Trigonometry. In this chapter, you are studying the basics of trigonometry, taking right angle triangle. Students, please note, this is not the correct way of defining trigonometric functions, but for the beginner, this is the most convenient way. In next 11th and 12th standard, you are going to study trigonometry at a higher level, where we are using coordinate system and then you are introducing trigonometric ratios. But here for 10th standard level, this idea is sufficient because it is very simple to understand the concept of trigonometric ratio when you take right angle triangle. Therefore, with the help of right angle triangle, we are going to study trigonometry. Let me clarify some of the things in the beginning. Trigonometry is a branch of mathematics. Here, it is the branch of mathematics where we are studying the properties of triangle and other things using the angle as the basic concept and also the sides. So this is the idea, and then it has lot of application. For example, suppose you want to find the height of a building without measuring it, you can do it. Suppose you want to find the width of a river, you can find it like that. Even suppose a aeroplane is flying at a particular height, you can find the height of the airplane, you can find the speed of the aeroplane using the concept of trigonometry. It's very interesting branch. And another thing is, this is one of the most important branch which is required for study of mathematics at higher level. Therefore, you have to study them properly. But let me tell you one thing in the beginning. Proper knowledge of algebra, arithmetic and geometry, they are a must for understanding trigonometry. I hope you are very comfortable with all these basic ideas of algebra, then geometry and arithmetic. Trigonometric ratio. First, let me define what is the meaning of trigonometric ratio using a triangle. So consider a right angle triangle. As I told you already, we are defining the trigonometric ratio taking right angle triangle. So I am taking a triangle ABC where the angle B is 90 degree. So this is the diagram. So A, B and C, and B is 90 degree. So this is the first thing you have to understand. Next, side AB is called the base. You know this one. Side AB is called the base, or it is also called adjacent side of angle A. Now I am taking angle A. I have denoted by a mark actually. So corresponding with that angle, BA is called the adjacent side. And similarly, the side BC is called opposite side of angle A. It is very clear because it is opposite side. Then you know the name of the third side, AC, which is hypotenuse. So these are the basics required to define trigonometric ratios. Now let us define. We can define 6 ratios called trigonometric ratios. You know that ratio requires two quantities. So here what we are doing is, we are taking two sides of the triangle and then we define the trigonometric ratio. First one is sin A. In fact, SIN, it is not sin actually, SINE, and the short form is SIN, sine. You have to read like this, sin A, and that is equal to, definition is, it is opposite side of the triangle ABC divided by the hypotenuse. That is equal to, in the diagram, it is BC because BC is the opposite side and AC is the hypotenuse. So this is the definition of sin A. You have to just remember this, that's all. Sin A is a ratio. It is nothing but it is a ratio of opposite side of the triangle. And what is the meaning of opposite side? It is the opposite side of the angle A. Then divided by AC. AC is hypotenuse. Similarly, cos A we define as adjacent side by hypotenuse. That means we are taking other two sides. So this is equal to BA divided by AC. Similarly, we can take tan A, another one more ratio, that is equal to opposite side by adjacent sides. So this will be equal to BC. BC is the opposite side, adjacent side is BA. Now we can define 3 more trigonometric ratios just by taking the reverse, that is reciprocal. Cosecant A equal to it is hypotenuse divided by opposite side. You can see it is the reciprocal of sin A. See, in sin A it is opposite by hypotenuse. In cosec A it is hypotenuse by opposite, and that is equal to AC by BC. Similarly, we can define secant A. This is equal to, it is the reciprocal of cos. So it is hypotenuse divided by adjacent side. Therefore, that is equal to AC by BA. And one more ratio is remaining. That is the reciprocal of tan. That is cot A. That is equal to adjacent side by opposite side. And that is equal to BA by BC. Let me conclude here. Sin, when you write it is SIN, you have to write, that is the short form, but while reading you have to say sin A. Similarly, cos means actually cosine, COSINE, cosine A, but we write in short cos. Similarly, tangent A, it is complete form is tangent A, but we call it as tan A. Similarly, cosecant A, that we call cosec A. Then secant A, we call it as sec A or sec A. Then cot A, that is called cotangent A, actually full form, but it is cot A. So these are the 6 trigonometric ratios. Then this you have to remember. So take any triangle ABC where you define what is any angle you can take as 90 degree. Then you take any other angle for defining the ratio. So this is the first thing you have to understand. So these are the basics of trigonometry. Now let us proceed. Relationship between different ratios. This is very interesting. Take the triangle ABC as before. B is 90 degree and let us take the angle A. Now sin A equal to opposite side by hypotenuse. Therefore this is BC by AC in the diagram. Now cosecant A, let us take. This is equal to hypotenuse by opposite side and that is equal to AC by BC. Therefore, when you multiply, that is sin A into cosecant A, what do we get? This will be equal to BC by AC, that is sin A, into then AC by BC. Now you can cancel AC and AC and you can cancel BC and BC. Therefore, you get 1. So this is very important result. Therefore, you can say sin A into cosec A is 1. Or you can also say sin A equal to 1 by cosec A or cosec A equal to 1 by sin A. This is the relationship between sin A and cosec A. This you have to remember. Next, let us take cos A. Once I have explained the sign, you can definitely understand this one. This is a repetition actually. Cos A equal to adjacent side by hypotenuse. We know the definition, that is BA by AC. Similarly, secant A equal to hypotenuse divided by adjacent, that is AC by BA. Now we have to take cos A into sec A, that is equal to, so BA by AC into AC by BA. As before, you can cancel AC and BA. So you get 1. Therefore, you can also say cos A into secant A equal to 1 or cos A equal to 1 by sec A. Similarly, sec A equal to 1 by cos A. So this is the relationship between the two ratios cos A and sec A. Next one. Let us take tan A, that is opposite by adjacent. In the diagram it is BC by BA. Cot A, it is the reciprocal, that is adjacent side by opposite, that is BA by BC. Now let us take the multiplication tan A into cot A and that will be equal to BC by BA into BA by BC. Once again we can cancel BA and BA and BC can be cancelled. So you get 1. So what is the result? Therefore it is tan A into cot A equal to 1. Or we can also remember this way. Tan A is same as 1 by cot A and cot A is same as 1 by tan A. So this is the relationship between two pairs, pairs of ratio, that is sin and cosec, cos and sec, and tan and cot. Next, one more important relationship is there. there is a relationship between sine A, cos A and tan A. So let us see. Consider the same triangle. Sine A, we know it is opposite side by hypotenuse, but that's equal to BC by AC. And cos A, we know it is adjacent side by hypotenuse, therefore it is BA by AC. Then tan A, we know it is opposites by adjacent, that is BC by BA. Now let us take cot A, of course cot A also we can take, adjacent side divided by opposite side, so this will be equal to BA by BC. So these are the four ratios. Now let me take sine A divided by cos A. Now let us substitute. What is sine A? Sine A is BC by AC divided by cos A is BA by AC. Now you can cancel AC and AC. Therefore, you get BC by BA. But what is BC by BA? You can see very well here it is tan A. Therefore, the relationship is sin A by cos A is tan A. Similarly, if you take cos A by sin A, that will be equal to BA by AC divided by BC by AC. As before, you can cancel AC and AC. What do you get? You get BA by BC. What is BA by BC? This is equal to cot A. Therefore, you can remember this relationship. Sin A by cos A is tan A and cos A by sin A is cot A. And you can cross multiply also. You can also say sin A equal to tan A into cos A equal to cot A into sin A. So these are the basic relationship. Now let us try to understand some of the important properties of these ratios. First one, sin A and cos A cannot be more than 1. This is very important result. Consider any triangle, say ABC, where A is the angle and B is 90 degree. Now you see, according to definition, of course, in the diagram you can see BC side is always less than AC, because in the triangle, right angle triangle, hypotenuse is the greatest side, the longest side. Therefore, BC is less than AC. Therefore, what is sin A now? Definition is opposite, that is BC divided by AC. So, the side BC is always less than side AC. Therefore, definitely it should be less than 1. Therefore, you should remember sin A is always less than 1. Of course, it can be 1 also, but I don't want to discuss all those things here. That is not necessary at this stage. Maximum it can take 1. It can be 1, not more than 1. Similarly, AB is also less than AC, other side, base. Therefore, cos A, if you take it is AB by AC, this is also less than 1 in any right angle triangle. So, these two important properties you can remember. Then, tan A and cot A can take any value, because, see here, what is the definition of tan A? Tan A is opposite by adjacent, BC by AB. If BC is more, AB is less, it is more than 1. If BC is less and AB is more, it is less than 1. Therefore, it can take any value. Same thing for cot also. This is another important result. And cosecant A and secant A are more than 1, because it is the reciprocal of sin A and cos A. So, there what happens? AC by BC. So, it is more than 1. And AC by AB, that is also more than 1. So, this is another important result. So, because BC is less than AC, cosec A is AC by BC. So, it is more than 1. Similarly, AB is more than AC. Sec A is also AC by AB. This is also more than 1. So, this you can remember. And next one, trigonometric ratios are numbers as it is ratio of two sides. So, what is, for example, sin A? Sometimes students get confused. Sine of an angle is not another angle. It is only a number, because it is the ratio of two sides. So, it is simply a number. So, this you have to understand. So, these are some important aspects of trigonometric ratios. Let us proceed. Important result. This is another important result which you have to understand. Consider a triangle ABC with, of course, B is 90 degree. Now, what you have to do is draw QP perpendicular to AB and also SR perpendicular to AB, two perpendicular lines. Now, you know that triangle ABC, triangle APQ and triangle ARS. They are all similar triangles. This you have studied in. Therefore, I told you in the beginning, proper knowledge of geometry is a must for understanding trigonometry. In the diagram, you can see that three triangles ABC, then APQ and ARS. They are all similar triangles. And what is the important property of similar triangle? The corresponding sides are proportional. That is another important result. This property actually we are using. Now let us take sine A for example. What is sine A? It is by definition, if you take the first triangle ABC, it is BC by AC. But this is also equal to RS by AS. AR, RS by AS, hypotenuse, corresponding hypotenuse. Similarly, this is also equal to PQ divided by AP, corresponding hypotenuse. And you know that all these are same because they are proportional. That means whenever you want to define a trigonometric ratio, it does not depend on the triangle you take. It only depends on the angle A, not the triangle. You can take any similar triangle, ratio will be same. So this is one important thing. This is applicable to all other ratios. Once I make it clear from sine A, it is also applicable to all other. Therefore, whether you take the first triangle ABC, or you take the second triangle ARS, or you take the third triangle APQ, sine A is same. Similarly, cos A is same, tan A is same, and all the remaining three ratios are also same. So this is one important understanding. This shows that trigonometric ratios depend only on angles, not on the triangle. Another thing is, you have to understand this also, because in the future we are using this concept. Sine square A means sine A the whole square. For example, sine A is what? For example, BC by AC. So sine square A means it is BC square divided by AC square. So square is written between N and A. There, that is very important, and you have to read like this: sine square A. So that's the way of reading. So this is another important concept you have to remember. Now let us work out one example, very simple, very interesting example. Examples on trigonometric ratio. Question is this: given one trigonometric ratio, we can find the remaining trigonometric ratios. How many ratios are there? 6. So if 1 is given, for example sine, you can find the remaining 5. So this is one important thing. Let us take one example. If sine A equal to 3 by 5, find the remaining trigonometric ratios. So solution: given sine A equal to 3 by 5. Now let us take any triangle, say ABC. Of course, what is the condition now? One triangle should be, angle should be 90. That is B, we will take 90. Then we can take A. So therefore now sine A equal to opposite side by hypotenuse. Therefore this equal to BC by AC. But that is given to be, see here very important is, even you can take BC equal to 3 and AC equal to 5 also. But instead of that, the best thing is you take BC as 3K, because look at the ratio sine A. It is opposite side by hypotenuse. What is the opposite side? BC. So BC we have to take 3K. Then AC we have to take 5K. AC is hypotenuse. Now what you have to do is, if AC is 5K, BC is 3K, since the triangle is right angle triangle, using Pythagoras theorem, definitely we can find AB. What is AB? It is square root of AC square, that is hypotenuse square, minus the other side, that is BA square. AC square minus BA square, and that is equal to, so BC square. Therefore 5K square minus 3K square, AC square minus BC square. So this will be equal to, so you can calculate, it is 5K square is 25K square, 3K square is 9K square, 25 minus 9 is 16, therefore it is 16K square. You can definitely take the square root, it is 4K. Therefore the base is 4K. So now what you have done is, you have determined all the three sides of the right angle triangle. Now you know the definition of trigonometric ratio, find it. So cos A, what is the definition? You have to write, it is BA by AC. BA, that is adjacent side, AC hypotenuse. Therefore, it is 4k by 5k. Definitely, we can cancel k. So, it is 4 by 5. Similarly, because the question says you have to find all the remaining tan A. Tan A equal to BC by AB, opposite by adjacent. So 3k by 4k, so 3 by 4. Similarly, cosec A. Cosec A equal to AC by BC, that is equal to 5k by 3k, that is 5 by 3. Similarly, sec A, you can write AC by BA, it is the reciprocal of cos actually. So cancelling k, we get 5 by 4. Similarly, cot A, which is the reciprocal of tan. So BA by BC. So that's equal to 4k by 3k. So 4 by 3. So these are the remaining 5 trigonometric ratios which we determined. So this is how one trigonometric ratio given, you can find all the remaining using the triangle. Now let us sum up, because I have taken a lot of concepts of the beginning of the trigonometry. Let us sum up what we have done. So 6 trigonometric ratios you have to remember. Take any triangle ABC with B 90 degree. A, the triangle angle. Sin A equal to, what is the definition? It is opposite side by hypotenuse. It is sufficient if you remember this rule. Side, you can just referring to the diagram, you can write. Here it need not be always B 90 degree. If you take A 90 degree, other two you can take. Therefore, what is important is cos A is adjacent side of divided by hypotenuse of the triangle. Similarly, tan A is opposites by adjacent. Cosec and sec and cot you can remember as reciprocal. That is very simple. What you have to do is first write sin cos tan. Opposite by hypotenuse, adjacent by hypotenuse, opposite by adjacent. First 3 basic ratios. Then cosec, sec and cot, just reverse, reciprocal of the first 3 ratios. Cosec and sine, similarly cos and sec, and then tan and cot. So these are the 6 important trigonometric ratios. Then what did we study? Relationship. So these are the relationship. This also you have to remember. Sin A into cosec A is 1, or sin A equal to 1 by cosec A, or cosec A equal to 1 by sin A. This is one important result. Second one, cos A into sec A is 1, or cos A equal to 1 by sec A, or sec A equal to 1 by cos A. So this is the next one. And similarly, tan A into cot A is 1, or tan A equal to 1 by cot A, or cot A equal to 1 by tan A. So these basic relationship you have to remember. There are 2 more. One is tan A. What is tan A? It is same as sin A by cos A. And the last one is cot A equal to cos A by sin A. So these are the basic relationship you have to remember. So in this lesson today, what we have done is we have defined 6 trigonometric ratios. Then we have also studied the relationship between them and some of the important properties. For example, sin A and cos A cannot be more than 1. Cosec and sec A cannot be less than 1. Tan and cot can take any value. All these basics you have to understand, because every time no teacher will tell all these things, because whenever you want to solve the problem, these are the things you have to remember. Thank you students for watching this video. As I told you, I have already started uploading the videos on all the chapters. Of course, I am very sorry for delay, because I have to prepare the PPT in a systematic way. So it takes time to upload. But please note, I will be uploading all the lessons of 10th standard CBSE step by step. So I have now started the trigonometry, because remaining in the big, I have started with the first chapter. That is completed. Then second chapter I have completed a little bit, but a few things are remaining. Now because students need trigonometry and coordinate geometry, because some students suggested me, therefore I am uploading trigonometry and coordinate geometry. Shortly I will be uploading coordinate geometry also, that is chapter 7. So please watch all the lessons and subscribe if you have not yet subscribed, and share with your friends, so that it is an encouragement for me. So I will be motivated more and more, and I will definitely improve my lesson and upload. So please subscribe and share. Let us meet in the next lesson with some more very simple, very interesting examples on trigonometric ratios. Till then, bye. Take care.